Hello everyone and welcome back. We're looking in this video at question number 4, A4 to be precise, on our 2018 Canadian Senior paper. Suppose that n is a positive integer and that a is the integer equal to 10 to the 2n minus 1 divided by 3 times 10 to the n plus 1. So that's things like 11, 101, 1001. Okay. If the sum of the digits of a is 567, what is the value of n? Okay, so one thing we could do with this question is, play around with it. What do these sorts of numbers look like? And if you, for example, try n is 1, you'll get 100 minus 1, so 99 on top. Divided by 3 times 11, you'll just get 3. So that's what happens when n is 1. If n is 2, you'll get 10 to the 4, so that'll be 10,000 minus 1, and that'll be 9999, divided by 3, divided by 100 plus 1, so 101, and that'll be 33. So when n is 1, there was 1 3. When n is 2, there's 2 3s. We could try it again. 10 to the 6 is 1,000,000. Subtract 1, you'll get 6 9s. Divide by 3, and then you'll get 10 to the 3 plus 1 is 1,001. So divide by 3, you'll get the 333, 333, and divide by 1,001. We are just sort of going to take this first little segment, and that'll be 3 3s. So when n is 3, we get 3 3s. When n is 2, we get 2 3s. When n is 1, you get 1 3. And in fact, there's a reason for this. Okay. 10 to the 2n minus 1, I'm going to rewrite as 10 to the n squared minus 1. And this is a difference of squares, because of course 1 is 1 squared. I can write that as 10 to the n plus 1 times 10 to the n minus 1. Now when I take that and I plug that into my expression, well, the top and the bottom will cancel a little bit. And you're left with 10 to the n minus 1 over 3. But 10 to the n minus 1 is always going to be, well, we can actually write it out. It's 1 followed by n zeros minus 1. And if you subtract 1 from 10,000 or 100,000, or a 1 with 10 zeros or 12 zeros or 50 zeros afterwards, you'll just get a number with that many 9s. So if I have n zeros, I'll get n 9s. And if I divide that by 3, I'll get, well, each of these 9s divides by 3, and I'll get a number that just is n 3s in a row. Okay? So the pattern that we see with 1, 2, and 3, it does continue on. So there's the mathematical sort of reasoning or proof behind it. But of course, you don't need to know that. You can just take a look at the pattern and make a good educated guess. Remember, it's a Part A question. No one cares how you got the answer, as long as you get the right one. But if you're unsure, you want to be able to write down this sort of reasoning. Okay? You want to be able to get part if you're not entirely confident of your of your answer. So the sum of the digits is always 3 times n. We've got n 3s. We add them all up. So if I know the sum of the digits is 567, and I divide that by 3, we'll get what? I don't want to reach for my calculator right now. 3 goes in there once. 8 times. 9 times. So 189. So n is 189. Okay. So there we go. And that was, oh gosh, is that 3 or was that 4? That was question 4. So up next, we're going to take a look at question 5, which appears to have an interesting looking hexagon, but we will get to that in the next video. Until then, take care, and thanks for watching.